ladies and gentlemen, good afternoon. I'm very happy to be in this exhibition of Nieuwe Energie, especially because one of my sources of inspiration, Mr. Gerrit van Bakel, is one of the artists, and he died in 1984, and I'm very happy that he is also in the exhibition, and I'm in the same exhibition. It happened before, but it was my initiative to do that, but this time it came from above, from hoge hand, werd ik bij Gert van Bakel gebracht. Anne-Martine already told that I'm very busy making new forms of life, and these forms of life are not based on protein, like our bodies are all made of protein. You could say that the creator, he restricted himself very much in the choice of his material. He just used one material to make us, just protein. And you wouldn't say that if you try to fry an egg and you put it in the pan and you see that clumsy material, that it's the ultimate construction material of life. But obviously, when you have millions of years of time and you try again and again, and that's what protein does, it produces itself. So it tries again and again. And the result is not bad, I would say, as we are sitting here, after all these millions of years, just one material, and it tried again and again. So that's the same strategy I would like to walk, to do it again and again. I don't give up the first time. The only thing is I don't have billion a year to do this, so I have to work very hard to do it in the coming 20 years. I can still work. I would like to introduce my work by showing a video. We go to play, and
pollen or seeds, but by making new creatures. In the computer, it's the numbers which reproduce themselves. In real life, it's biological cells which do the same. So in fact, the numbers are equivalent to the cells. Apart from the numbers in the computer, Theo Jansen recently found another alternative for the biological cell, the electricity tube. With this, you can build structures very quickly. You can build arms and legs, and subject to selection. Reproduction. Selection. Sometimes the selection and reproduction takes a side road via numbers in the computer. Evolution goes faster in the computer. The result is that the artificial beast finds its most efficient way to move its feet. Eventually, these beasts are going to live in herds on the beaches. Theo Jansen is working hard on this evolution. The mechanical beasts will not get their energy from food, but from the wind. The wind will move feathers on their back, which will drive their feet. The beast walks sideways on the wet sand of the beach with its nose pointed into the wind. As soon as it walks into either the rolling surf or the dry sand, it stops and walks in the opposite direction. There have been many experiments. evolution has generated many species. The knees of the Animaris vulgaris sagged a second after it was put on its feet. You could also say that the beast lived for just a second. Most species died out. For some, just parts are left over. A problem for beach animals is the dry sand. There's a chance that they'll get stuck in it. The Animaris speculata was a little beach animal which remained connected to its mother. It was used as a scout in the dry sand. When walking cost too much energy, the little animal would warn its mother, who was able to pull it out again. Another problem was the wind. When storms came up the beach, the animals used special tools to prevent them blowing away. The Animaris arena rolled out a trunk. At its end, a hammer tried to drive a pin into the ground, so that the beach animal was fixed. The Animaris sabulosa had a more secure way to prevent blowing away. It had a spoiler on the front, which would push down the nose. This is the Animaris currens ventosa.
I would like to explain the leg system. Can you see this? Yes, thank you. So in the middle of each beach animal there is a sort of spine, a backbone, which make a circular movement like this. And you see, every time when this circular movement is transformed to a complex movement down there, so every time it puts its foot on the ground, the pencil there draws a straight line. Somehow it's stuck, I don't know. Okay. So this straight line, and that means that the animal stays on the same level. So just like the axis of a wheel. In fact, this is a reinvention of the wheel, because a wheel doesn't use much energy, because it stays normally when you walk, you toss up and down, and this leg stays on the same level. So it has the advantage of a wheel, but wheels are not on the beach very handy. Try to cycle on the beach, and you notice that it's very heavy because the wheel has to touch every point of the path, and legs just leap over. They skip pieces of their path. So legs are a lot better on the beach than wheels. Now, the shape of this curve, so with the flat bottom, is very dependent on the length of the tubes in between here. If you have a different proportion of length, the pencil will make another drawing. And when I started this, I didn't know which proportion I needed to get this shape. That's why I built a computer model of this. And then the computer can generate the curve. That was an Atari computer. Some of you will remember the Atari computer. And then still there are a lot of possibilities. For instance, if you have 10 possible lengths for this one, this tube, and 10 possible lengths for this tube, then you have already 100 combinations. And there are 13 distances which play a role in the shape of this curve. And if the Atari would let pass all the possibilities, it would be on for 100,000 years. And that's why I had to take the road to via evolution to get the right proportion. So I wrote a genetic algorithm, what they call it. So there were born legs in the computer. They were selected, and because of the shape of the curve, and that process of reproduction and selection went on for months, day and night, and there came 13 numbers out of the computer, which were the distances, the length of the tubes, and the 13 numbers you could see as a sort of genetic code of the beach animals. That's why I call it the holy numbers. The holy numbers, the 13 holy numbers of the beach animals, because they walk already more than 20 years on that sequence of numbers, this genetic code. Now, I brought a small beach animal. And you can see, well, I have to blow from this side. You can see that the body stays on the same level. Getting a bit dizzy now, but so the idea is that the body stays on the same level and just the legs, they move. And I would like to show you some images of the archives of the beach animals. Let's see if I can find them fast. So we skip some. This is a herd of animals which are all, well, they have a sort of genetic code as well. And this is a running match to see which genetic code is the fittest. And you can replace that code in the other animals. It has to do with the length of the tubes in the whole animal. There are 370 lengths of tubes, so 370 genes, you could say. In the next shot, you're going to see an animal which makes a wave pattern with the leg. So the waves start at the right side of the screen in a minute. It goes from right to left. And now it goes from left to right. Here's an animal busy storing the wind, so they can store the energy, and I will explain that later, because the animals have a wind stomach, so they eat the wind and they put it in the wind stomach. Here's an animal walking with a sort of ski sticks which pushes it forward. So the ski sticks are here, and every time it gives the push. And it has the advantage that it can also walk a little bit on the dry sand, the fluffy sand, So this animal just walks with the wind. So in the same direction as the wind, I must say. Here you see the ski sticks again. So on top you see the wind stomach, so the energy is stored in there. And I will explain that later. So you get a sort of muscles which you can, so now it walks the other way. So this is a totally different family. So this cardboard thing was a model to make a very big animal of steel. So the animal became almost 5 meters high, and it had a weight of 3.2 tons, and it walked quite well on the wind. But not this one. This is just a study as well in wood. And this looks like plastic tube, but it is steel. So it's just painted yellow. And this was the inner frame of the big beast, which was... So later it got a skin over it. You see these small wheels down there, and they are to adjust the speed of the legs, because they don't have the same speed, and to avoid a conflict between the legs. So there's some freedom in the small wheels. So here it had the skin on it, and you could really sit in there, in the cockpit. And we tried it on an airport runway, and it walked too fast on the wind. It broke itself. 3.2 tons, so 3,000 kilos. It's like a truck, you could say. So I would like to explain more about the storing the wind. So this is my protein. So I try to make everything of my protein. Can you hold this, that everybody can see it? Thank you very much. Hey. What's happening? So there. Thank you very much. Well done. So this is there's a small O-ring on this inner tube, and you have a piston. Now, this pump, you could say, is connected with the wing. So when the wing moves, it pumps. And it pumps air in soda bottles, in spa bottles, PET bottles. And so it presses the air in there. You could see that there's pressed wind. There's pressed wind in the bottles. And this is energy. And that's a stored energy, a stored wind, you could say. It's a potential wind. So when you open the bottle, the wind comes out again. And you can use that energy just to when it goes into a pump, it stretches just like a muscle. So you have a sort of muscles. And muscles turn out to be very handy if you want to survive on beaches. Because muscles, they become bigger on command, and they can open valves. Muscles can open valves which activate other muscles, so you can make networks of muscles and what are called nerve cells. I will explain the nerve cells. This is a nerve cell. It's quite simple. I will explain it very clearly for you. So if you don't know anything about technology, you will understand how the nerve cell works. It has an upper part and a lower part. And I start with the upper part. Now, if I blow in here, the air goes in here and comes out from this small tube. So this is a connection. But there is a piston here. If I push it up, like this, it's closed. So, open, closed. It's just a valve, een kraantje. And this is a very small muscle. If I blow here, then it pushes up. So when I put this way, then if I blow in air in here, no air comes out of this tube, right? Because it closes the valve. So this output is opposite from the input. Got that? So if you see this, to make it more clear, if you see this as a person, and this is the mouth, and this is the ear, then the mouth says the opposite from what it hears. If air in there, no air comes out of here, right? So that's why I call this a liar. If it hears yes, it says, very good. Okay. Now imagine that, let me see, that you are a liar. I know you're not, and you are a liar, and I'm a liar, and I say to you, yes. What would you say to him? No. And what would you say to me? Yes. And I say no. In this conversation of three liars, I changed opinion, right? So that's what you have with an uneven number of liars, that you change opinion all the time. So that's what I call a dynamic system. If you have two liars, you have a static system, so you keep saying the same thing all the time. And with three liars, you have a dynamic system. So I have three liars here. So this is you, and this is you, and this is me, and we're connected. Our ears and mouths are connected, and let's see what they have to say to each other. So they're saying yes and no to each other. As you know, you can see a yes as a 1 and a no as a 0. So in fact, this is a sort of bit in a computer. And you can make networks with these liars, which are quite complicated. You can make step counters, so they count their steps so they know where they are on the beach, the beach animals. And you can also make time mechanisms which run parallel to the tides. So what you see, in fact, here is the future of the beach animals. It's the brains. And so in the future, they will have special walking units carrying it's a very heavy brain. So they have to carry the brains of the animal. They also have senses. Like this is the water feeler. So, well, I will try to explain. This tube is vital for surviving on the beach. It feels the water. It means, well, it's sucking in air all the time. And as soon as it arrives in the sea, it swallows the water and it feels the resistance of the water. And then some switch goes over and then it runs out of the sea again. That's the idea. Now, we're going to test the water feeler now here. And we need something to indicate that it really felt the water. So we have a glass of water here. So this is the sea. Oh. Okay. It's a bit enthusiastic. Well, I need some help. Can you help me? Thank you, Anna Martina. Can you hold it here and there? So don't touch the elastics. That's perfect. Very good. And we get some more water in there, right? Now the water feeler only works in 50% of the cases. So if you see it work, you're lucky. And so I'm going to open a valve, and it's going to move in your hands. But I know you're a very brave girl. So, yes, okay. Are you okay?
Yeah.
Oh, yes, I forgot. We need something to indicate that it really felt the water. So we're going to take some layers of this one, and we're going to connect it to this one. I hope I did the right connection. Yes, I think so. I'm not sure. Yes, I did the right connection. And so it's going to start moving again. So when it touches the water, the layers should talk to each other. Got that? So we're going to put it in the water now. Yes. Wait a minute. Come on. Yeah, sorry. Well, usually it works. No, Anna Martina. Thank you very much. You did your work quite well. So I want to do the water feeler later when you're all gone. And it will work, I'm sure about that. Now I want to continue with the last subject of today, and it's the multiplying of the beach animals. I always thought that beach animals would multiply by feeding them tubes, and then they would work on the tubes, and they would build another beach animal. And that, of course, would be wonderful if they could do that. And they could do that, but I need another 1 million years to realize that. So, but behind my back, the strand beasts were already multiplying very well, and I didn't realize that. Because if you look on the internet and you look on YouTube and you type in Theo Jansen mechanism, you find hundreds of students who make strand beasts. Now, of course you will say, well, this is not really multiplying because you use people to do that. And in fact, that's true. The strand beasts use people to multiply. You could see the strand beast as a sort of virus which comes into your mind. It came into my mind 21 years ago, and they make you sick, and they give you sleepless nights, and from that moment, you're really infected. You can do only one thing, and that's making strand beasts. And this virus turns out to be epidemic. It's a meme which goes into people's brains, and some people are really infected. So in Japan, they're ordering now my protein. Oh, sorry. At the Dutch factory where they make this, because this is a very Dutch product, so they have to order it in Enkhuizen. And they order lots of plastic tube to make strand beast in Japan. And this thing is assembly kits which they produced in Japan as well. So, well, they made 20,000 of these. So they multiply like rabbits, you could say. And this is the rhinoceros. Well, one part is missing. On top there's a sort of thing which runs into the wind. So this animal walks against the wind. And it's also produced in Japan. So it's a model of the rhinoceros. And very recently, the stage of multiplying went a level higher. So this very small animal, it's not assembled, it's born. It's a born animal, and it came out of a 3D printer. So what happens is that you make a 3D model in a computer, a virtual model, and you do Control P, and then this animal is materialized. And the idea is, how it works is that there's a layer of nylon powder. So the printer puts a layer of nylon powder on a plane, and then a laser burns the nylon powder together. It melts it, so it sticks together, it becomes hard. And then the next layer comes over it, and layer by layer. And you end up with a box full of nylon powder. And this thing is in there. So you just have to blow the nylon powder off it, and it runs over the table. Oh. Okay, ladies and gentlemen, thank you very much for listening to my story.